Yeah, so that's really interesting. Yeah. Yeah. All right, so what I realized is that I didn't have my mic on that entire time. So nobody could actually hear me, which definitely changes things quite a bit.
That's hilarious.
But that's okay, because we can go ahead and review. So, big apologies for that. I have 0 concurrent viewers now. That's probably why I have 0 concurrent viewers. Sorry about the mic issue.
Looking to
That's
no
on
one
me.
right now.
Okay, well, somebody might join, and people watch these things on playback sometimes. So, big apologies to all of that. Let's review. Right now, we're trying to find the boys on the periodic table. We've had some decent success so far, but it's been a little bit confusing. We have found Owen, OG, on the noble gases. I am going to quickly tell Luke that I am very deeply sorry for the mic problems. Sorry, I fixed the mic. Yeah, so I probably should have unmuted that before I started streaming, but things like that happen. Anyway, so we found Owen in the noble gas section. As we know, noble gases have 8 valence electrons, which means they're a pretty stable element, not really necessarily looking for a bond. So it's pretty clear that we found Owen there. You may be wondering where the G comes from. That's from Owang. If you know a little bit about the boys, then you would know that that is obviously going to be Owen there. Next, we found Isaac. SC, scandium. We talked about how in the transition metals you can't necessarily know how many valence electrons they have. It can be kind of different depending on what's going on, depending on the day. So that is a little bit weird, and Isaac is also a little bit weird. He can be pretty confusing. You don't really know if he's gonna have a positive charge or negative charge. He's gonna be acting depending on the day. It can be different. So just a little bit of review there. Sorry for the mic issues. So we found SC, SAC, OG, Owen. Been through a few ones for me. I could be rubidium. Responsibility would be an alkali metal. Definitely wants to bond quickly, so that makes sense. But it's looking probably like muscovium here, just because it is my initials, Mark Cruz. So like it would be very strange to not expect that to be me. Anyway, we were looking for Jonah before the mic collapsed here, so I am going to say with, pretty clear certainty that I think we can find Jonah right here in the alkali metals at potassium. Jonah's a really nice guy. Jonah can bond with just about anybody. Really chill guy. And he's got a positive charge because he's a positive guy. So K plus, that's gonna be Jonah, very clearly, right there. And the K is obviously for Caliphate. Not leaking everybody's names on the stream or anything, that would be weird. Let's find Will. All right, so already we've got a W here, and that's gonna be tungsten, which is a transition metal. A little bit strange. Will's a little bit of a weird guy. But I would say that we should keep looking. We don't just jump on the first thing we find. So let's go through this a little bit. Could be helium, Hestad. He, that would make sense, but that would require him to be a noble gas, which would mean that he would have to be stable, and I would not say Will is very stable, so we're going to go ahead and cross that out. Alright. Will, do you actually know where you are on the periodic table?
No.
Okay, well, we're going to find you. Let's see here. Gotta take into account the C's too. Will chill, so you know. Got to check that out. So we're going to look at W as a possibility. That's tungsten. But we will keep searching for now. Looking around, I'm not seeing any obvious options. But we will keep looking. All right, so I'm getting some intel here. Really interesting, actually. Will is actually not on the periodic table. And you may ask, why was Will not on the periodic table? I thought we were finding all the boys in the periodic table. Well, you see, Will is actually a compound. And so you can't just find Will on the periodic table. He's a little bit more complicated than that. So if you're trying to get Will, there's kind of a few ways that we can do that. And I'll show several of them. One is just the single Will atom here, and you can get that by applying excuse me, what's basically going to be 2 iodine atoms with a tungsten atom here, and that's going to be I'm sorry, I did that wrong, excuse me, 4 iodine atoms with 1 Will atom here. That's going to be Will Chill 04, just like the gamer tag. So that would be one way to do it. Obviously the Will here, that's going to have a +4 charge, and then each iodine, we know because it's in group 17 here, is going to have a -1 charge, so -1 times -4 equals to dot gives you a neutral charge. So that is one way that you can get the Will. Another way, and we already talked about this earlier, Will, I know, but you can technically apply this as a polyatomic ion. So you'd put it in parentheses, and normally polyatomic ions go after the other element, but in this case it's a very strange element, but you can actually put the Cl after the Will Chill polyatomic ion. This polyatomic ion has a charge of +1 altogether, and so it's going to balance out with the chlorine. Generally though, we're just going to keep it like this, and that's going to be Will right there. So Will's a little bit of a harder find, but you know, you can't expect everything to be easy in chemistry, so things like that happen. Anyway, we are still trying to find Luke and Jacob. If you are joining us now, you can see that we have 0 concurrent viewers, so looking good. Always appreciate the viewers, even when there's none of them. Anyway, let's see if we can't find Luke. And it is possible that Luke or Jacob could be compounds, and that could be why we're struggling so much here. So let's just keep looking around and see if we can't find anything. Oh, I found Luke. There he is. Lu, lutetium. Now, I did not expect that. You told me to look for Lu, Will, but I did not see that off the bat there. So he's actually going to be in the lanthanide series here at the very end. So let's go ahead and put that in here. So Lu, it's going to be Luke. Okay. So I don't know a ton about the lanthanides and kind of how they behave, but I definitely think that, let me respond to a text real quick. I definitely think that there's probably something involved with that, and why Luke would be Lu down here in the periodic table. I mean, we'll probably Google that and see if we can't find some common compounds in a minute, but again, if you're just joining us, just to review, we have already found Owen, Isaac, and Mark Jonah, and then Will is going to be a compound. So that leaves us with Jacob. And it is getting a little bit weird here, but it is looking like we have a few different options. I'm looking at lead, PB. Jacob is kind of a peanut butter and jelly sandwich. So lead could be a possibility. I think Pilgrim as well. Still looking at your terbium. That would be, because J's and Y's, they used to be kind of in the same vein back in, ancient times and things like Latin. So, could be that, but I think we're getting a little bit closer when we start looking a little bit closer at the P's, and so you can see phosphorus right here. It may be kind of sticking out at you if you've been looking a little bit closer than I am, and that is actually probably where we're going to really get into it here. So there is actually two ways. So I'll go ahead and put the two ways for will up here so you can actually see that a little bit better. So that, and I should actually point out, I think I said that this was balanced earlier. This is not balanced. This would be the balanced version of will, so I'm going to put balance. This is actually a very unbalanced version of will, and why it bonds, we're not exactly sure yet. It's kind of one of those confusing elements because this is obviously going to have a positive charge, but chlorine here is going to have a negative charge, so it's a little bit of a strange kind of thing. But anyway, let's get into Jacob. So you've got two things for Jacob. One is going to be a covalent bond, which is our first of the covalent bonds here, PP. So that's going to be two Jacob atoms bonded together. That is one way that you could potentially get Jacob. Again, that is a compound, so I'm going to go ahead and put Jacob. However, there is another way you could do that, and that is going to be a ionic bond here, and it is going to be YB. P, and let's see here. So this is going to have a charge of -3, and we're saying that this has a charge of +2. So to get these to equal out, we're going to actually need 3 of these and 2 of these because that's our least common denominator. So let me make sure that's clear too. So that is going to be another way to get Jacob here. Again, in Latin, in some ancient languages, a lot of times the Y or the I stood in for J, which is a letter that was added. In the English alphabet, it's different phonetic. But anyway, YB3, P2. That could be one way you get Jacob. PP, other way. Both are balanced actually, but it gets a little bit weird there. There's kind of a lot of ions negativity there, but. Anyway, that's mainly going to be how you can get all of the boys. So before we end the stream, we're going to do just a little bit of, bonding work here. So you can see, again, Jonah is definitely going to be an easy one for most types of bonds. A very common bond would be a Jacob-Jonah bond, the double J there. So again, let's review. Jonah is going to have a -1 charge based on the fact that he is in group 1 and is an alkali metal here. Jacob, now you're not going to be able to bond the compound Jacob here, right? Okay, but you can just take part of Jacob here, the P, because you need a part of both people when you're making a bond. Otherwise, it's not really going to be an equal bond here. So if you take the P for Jacob here, phosphorus, and you add that here, let's think about this. Well, what group is this in? This is in group 15. So let's see if this has 8 valence electrons, 7, 6, 5, meaning it has a -3 charge. Because again, this is -1, -2, so -3. So if this has a -3, then you're actually going to need to get 3 Jonah atoms. And, excuse me, I meant that's positive charge, so my bad. Anyway, three of these, right, if you 3 times 1, is going to get that +3 charge, which will balance out this -3 charge. So that is going to be the Jacob, or excuse me, Jonah's first. Always name the metal first. Jonah Jacobide. So that's your Jonah Jacobide. Again, Jonah Jacob kind of be where most of the bonding is going to take place in some of these, but different things can happen. Let's show the Mark Jacob bond. So again, important to note that the Jacob has a -3 charge. The Mark ion actually has a +2 charge. So you're actually going to need 3 of these, and you're going to need 2 Jacobs in order to get a stable bond there. And again, always name the metal first. So Mark Jacobide. Let's see. Again, Will is already a compound, so bonding there is kind of already taken place. It gets a little weird and funky when you try to get some of those things together, but it is certainly possible. I think, one more that I'll point out before we stop. LUPP. So you've got a covalent bond in here, again, between Jacob. It should be double covalent, right? I think. Or is it triple covalent? Is PP triple covalent or double covalent? Do you know, Will?
No clue.
Alright, I'm gonna check this. Because they each need 3 valence electrons, right? 5
so.
valence or so. So wouldn't it be triple, right? Because they're sharing 3? I guess. Okay, so that's a triple covalent bond, but it's also bonded to this LU here. So that's a little bit of a weird one. That's the Luke Jacob. But yeah, I'm pretty happy with this. I think we found most of the boys on the periodic table here, and that's about all you can ask for with these types of things. So I guess when this gets uploaded, we're gonna have to take off the front half of this where the mic was not working. But again, appreciate all the views, everybody watching here. Shout out to Will for being here. And yeah, that's about it. We'll have more real content soon. This is just one of those things, just because I thought of it. And yeah, I think with that we'll end the stream.